Good afternoon. This is our project for our AI, which is called Advanced Crash Detection. Our goal of our project was to help keep roads safe through an AI which would be able to detect crashes utilizing 80,000 images and distinguish the severity of these crashes. Now, Ian will go over how our upload works and the front end, how it looks, along with some of the
All
back
right.
end.
So here you can just drag and drop or go through the file process and choose an image. This was extra. This part here was extra complicated because we ended up using two AIs. So we had to we used CV2 and we used the functions rectangle, put text to annotate. It would have been a lot easier if we didn't have two models, but you can see we have in the picture, it didn't detect anything. It's most likely because there's a fire and we never actually trained it on fire. So it can't recognize the shape of the car. But if we can do another image. So something like this, it can detect the crash really easily. And this here is kind of a product of null images because the overlap it can detect that it crashed. But if you farther back, more cars are overlapping. But in those cars didn't crash. And it's most likely because we use null images in our data set. And I think we're going to move on to about this.
Ian, would you like to cover the live feed?
Oh yeah, the live feed, sorry. The live feed uses the same type of method, except it's just same type of method as upload, except it's just pulling from a live camera, traffic cameras, and it's just constantly viewing them for crashes. Yeah.
Okay.
About us. So annually, 1.35 million people fall victim to fatal car accidents. And one of the leading reasons behind the high mortality rate is the time it takes for an ambulance to be dispatched and to stabilize the patient. The difference between 7 and 12 minutes can make up as much as 45% difference in mortality rate. So our main purpose of creating this AI is to accurately spot crashes and also hasten the response times of first responders. And next up, we'll move on to the buttons we made, which can both open and toggle. And I'll let Oliver start us off with the confusion matrix.
Because we use two models for our AI for vehicle recognition as well as crash recognition, we have two separate confusion matrices that both work in parallel. The crash recognition, well, let me just explain it. The confusion matrix works off of looking through the training set, and then it makes its prediction, and then it looks back to the validation set or like the testing set and whatnot, and then it checks those images to see if it was correct. And from this, it can gauge its accuracy, and based off of the training we did on it, which was differed from the data set we used. I think we ran like somewhere around like 400 epochs, which is the number of times that our AI ran through all of the images. It's a little hard to see on here, but for vehicle recognition, I think it got roughly like 98% accuracy for recognizing vehicles, but this was like strictly to its data set that was checking. So in real world application, it might not go as well. And for crash recognition, it's a little bit more skewed because we're looking from street cameras. So perspective plays a big role. Like for example, you're looking down a road at an intersection and there's two cars that look like they're overlapping because they're close to each other. And it might detect that as a crash, but in reality, it's just two cars close to each other. So the confusion matrix for crash recognition was a little bit harder to fine tune, and it certainly required a little bit extra effort, such as including null images so that it would function. in regular settings without just detecting car crashes everywhere.
Next up is our button on for how it works, and it sort of explains how our program works. Ian?
All right. So for our AIs, we were using YOLO v5, which is a computer vision machine learning algorithm, and we actually used two, as we previously stated. One was for detecting crashes, the other was for cars. The cars used 13,000 images. The crash one used 1,400. They both ran as many times as we could before they started overfitting. It was around 200 to 300 epochs for each one. And the car dataset was run locally on Oliver's computer, and we ran the crash dataset on Google Colab until it couldn't run anymore. We can move on to real world integration next.
In a setting where a minute matters, car crashes need to be responded to as quickly as possible. The amount of time it takes for a crash to be reported and an ambulance to be dispatched can take as little as a few seconds nor to 10 minutes. The major determining factor being whether you live inside an urban or rural area. Traffic cameras are stationed all across the United States, both urban and rural. With the application of AI, we hold the potential to dramatically reduce the staggering 1.35 million annual casualties to car crashes.
Now, the issues we ran into, Tab. So some of the issues that we ran into while designing this program were that our RoboFlow data set that we had originally annotated, we were unable to export due to some of the settings within the data set and within the project. We also found it difficult that Google Colab could not support the data sets that we did find online from RoboFlow and that we exported. For example, we were looking to use a more advanced Stanford data set, which had 27,000 images to in its training data set, which was its largest set of data. We were unable to use that data set due to the fact that Google Colab could not process it. Though we did find that running it locally did work for smaller data sets that were still suitable, not necessarily 27,000 images within the training set, but there were enough images that we felt our AI would be able to be accurately trained. Our program was also designed to be able to forward the data on an accident to first responders in an attempt to help speed up response times. Originally, we planned for phone numbers and input, but we were unable to make that work. So we have now resorted to email. And Nathan, if you'd like to show some of the emails that get sent. So here you can see that this is from one of the live feeds, and it tells you what was detected, the confidence of the detection, and which live feed it pulled from. As you can see, so motorbike was what was detected. We are unsure still why it is sending and saying zero confidence when there's a confidence that is being measured. And then the last part of that, Jackson Hole, Wyoming, is the actual live feed that it's pulling from. And then Zachary, if you'd like to talk about our team.
Okay, so this is our team section, which includes some really cool CSS. We have cards for all of our team members, and it includes a description about each of us. So the cards include a really cool hover effect and also have the ability to flip. Thank you for your time, and if you have any questions, you can ask us in chat or